hi everyone, welcome to another session, another learning training session where Scala has been known for a number of things, and one of them was Akka. But nowadays we came to know that it has been licensed, so you have to pay. But a very few of us know about that there is an alternative to Akka as well, which is known to be the Zio, and I believe it is one of the most emerging technologies ever going on. Even we are giving a number of sessions on Zio as well. So one of the most exciting feature from Zio is ZLayer, where our today's coach Niloy Chaudhary, who is a tech lead in Nodus INC, and today he will let us know about actually what actually is a ZLayer, the profit, the benefits, the use cases, and how we can use it. Means the demonstration as well. So let's keep the ignite up to learn about something new, which is about the ZLayer, the introduction to ZLayer. So the stage is all yours, Niloy. Please start the session.
Yeah, thank you, Goldibug. Yeah, let's. So before starting the session, let's go through our knowledge etiquettes. So please be punctual, and so that we can start the session in time and also conclude on time. Uh, we prefer that we keep our mobiles in silent mode, and in case of emergency calls, we can always attend the call by dropping from the meeting. And also, we want to avoid disturbances. And also, please provide valuable feedback so that we can work harder and present better. Okay. So let's start with the agenda for today's presentation. Before that, I am Niloy. So I'll be presenting today about the Z layer, which is part of the Zio ecosystem. So we will first introduce the concept of Z layer. What is it? Why we need it or we don't need it? What are the basic data types? And about module patterns. And finally, we'll have a live demo explaining the concepts. So I think we all agree that we like modular applications, right? Because we don't want to write 5,000 lines of code in a file. And this practice is not specific to Scala or functional programming, but it is practiced everywhere. So here, the Z layer basically describes or represents one layer in our application. And we'll have many more layers, and one layer will depend on another. So the Z layer, we basically represent the requirement as our input, which will provide us a service, or a layer as our output, or it also might fail with some error while trying to give us the output. So like Zio data type, Z layer is also a data type, which is a recipe basically. Nothing happens unless we run the effect. So it's a recipe to create service. Zio is like recipe to create an effect. It's a service. Compared to object-oriented style of programming, we can think of its service constructor basically. Some advantages of ZLayer are like we can compose multiple layers with different combinations. They are also effectful and resourceful. Resourceful in the sense it can acquire resource in a safe manner and release also. And we also have that all the advantages of Zio, like these are asynchronous and non-blocking. So this is just theory. We'll cover many of the things in the working session. So what are some important data types? So we all know or may not know that Zio can be represented or thought of as a function. Internally, everything is like a function in a functional programming, right? But lazily evaluated function kind of thing. So here in Zio, we have three type parameters. First one is R, which is like a requirement or environment, you can say, which give us results of A type, or either it can fail with E type. So basically we have R as input and either E or A as output. And our Zio layer is mostly concerned with this R type, that environment type. So we also have a hash type, which is used to define the environment in Z layer. So hash type is a wrapper kind of thing for a service. we can simply represent one service type as a dependency, but then has give us some advantages, like we can bind multiple services to their implementations, like map. We have map key values, right? So we can bind multiple services, and we can also combine multiple services, which we cannot traditionally do by inheritance. If I have to inherit from two types, right? We need to make code changes for every kind of possible combinations, and we cannot extract a specific type. So hash type give us these benefits. So finally, the ZLayer type. So ZLayer type is defined as one input environment, one output environment, and which might fail with some error. So one of the advantage of ZLayer is composability, like we can combine horizontally or vertically. So horizontal composition is like in ZO2, it is also called intersection type. It looks like layer 1, layer A and layer B. It's like union, but in fact, it is also kind of intersection because it describes the requirement both on layer A and layer B. And the vertical composition is like one layer depends on another layer to provide the output of the layer B. So we haven't spoken about architecture much, but when we define a big application, right, we try to divide the logic in different modules or different services. Uh, so one service can be thought of as a group of some features or functions that we group together, and it is focused only on a particular say concern. So when we define the application in terms of service, we get more modular codes. We can have multiple implementations for a same service, so we can test it better because we don't have to depend on each module or every line of codes. And dependency is exposed only as interfaces, so there is less coupling, we can say. So ZLayer is nothing but defining services in the ZIO world. So in ZIO environment, it is called module patterns. So simply define service pattern in terms of, like, we write a trait, we expose some method which will be used by another service or consumer, and then the implementation of service, we implement that method or in a multiple way, or we can also define dependency in terms of constructor, right? And in ZLayer, we provide as a service dependency. So one advantage of ZLayer is, like, in constructor type, it is blocking. And as we know, ZIO is fully non-blocking. And also in constructor dependencies, we might face circular dependency, right? When we have lots of dependency, one service depends on another. But by design, ZLayer will not come to that level. It will give error in the compile time itself. So how do we create a ZLayer? So Geo provides us a recipe for that. These are some of the steps which we will also implement. Basically, we give a name to the module or the service in a package object or some other object. Then we create a trait or wrap to declare the service, and we wrap that in a hash data type. And the fourth step is important, like we can create a Z layer out of some service or that implementations. And the last step is we also expose that as an accessor method. So accessor method will declare as a dependency. So this is actually module pattern 1. Zio also provides module pattern 2, which is uh, like much more kind of object oriented way. So till now, am I going very fast, or is it okay? Because I want to explore more in the demo session.
It's good, Nila. Actually, yeah, we
Okay.
are able to get it.
Okay. So we'll focus on the second last part, like how to define ZLayer. Uh, for creating layers, basically we need to think of two things. One is if the layer we are creating depends on some other layers, like declaring the dependencies. For example, if we define a database layer, it might depend on socket and blocking layers, or in some cases, some layer might be created independently also. And second concern is while creating the service, do we need to acquire some resource or handle some resource? That also we need to consider. So we don't have to write lots of codes for these things. Zio already provides lots of APIs. So once we are clear with dependencies and resource actions, Zio provides some methods to create us the layers. Actually, there are different flavors. So the very basic one is ZLayer.succeed, which we can create from a value or a service, but which doesn't depend on other services. Simply some value to ZLayer we can create. So similarly, we have ZLayer from functions, which translates functions input requirements into the requirement of the layer. Similarly, from effect, we can create ZLayer, and also from geo effect, we can have two layer to create a layer. Then we have ZLayer.service, which is actually depends on other services as dependencies. And we can create from one service dependency or multiple service dependencies. So we have appropriate methods for that. We also have methods for creating layers from managed resource. So we also have Z managed types, which are specific to acquiring and releasing resource safely. So from those also we can create Z layers. So we suppose we have created the modules. Uh, Now we need to bind them together and use them. So we can think of it as a dependency injection. Uh, so building dependency graph is like, as we mentioned before, suppose database service depends upon the lower level APIs. So if we need multiple layers, right, we can compose them horizontally. It's like we need both layer A and layer B. And vertical composition is where one layer depends upon the other layer. It's kind of direct input output. So once we define the dependency graph, next comes how we provide that. Because in object-oriented world or other scenarios, we have GUIs or other libraries which will inject the dependency once we declare it. But in case of Z layer, we need to provide that. For that, actually, we have multiple methods provided by Geo. So basic one is provide layer method. Suppose I have a effect which requires random and clock. Basically, these are inbuilt Geo modules services that we can readily use. It's provided by Geo framework itself. And I need to provide the layers to the app effect. So how would I provide it? App.provide layer. Uh, so this random.live is basically the layer which is defined inside the random module. We compose two layers horizontally and provide. So whatever is the requirement for the app layer, we are providing everything. So that is provide layer. We need to provide every dependency. Next method is like provide some layer. Suppose we have a requirement for three layers: random, clock, and console. And at this point of time, based on the application logic, I want to provide only console. So I get a new effect which still depends upon clock. So only one layer I provided, it still depends upon the another layer. So these are kind of flexibilities that we don't have in the constructor based dependencies. And the third important method is provide custom layer. As I mentioned earlier, Geo system already provides lots of inbuilt layers like console, clock, blocking, etc. And in addition to that, if I have a effect which depends a custom layer like my service along with the inbuilt layers, then I can provide only the custom layer, which is my service, and it will still require the inbuilt layers. Of course, those will be provided automatically by the Geo environment. So that is about dependency injections. So let's see everything in action. Let me switch to ID. To save some time, actually, I have created a project. Nothing fancy, just Scala and Geo dependencies. Then I have defined a few packages. So basically what we'll do, we'll have three modules, one logging, one business, and one controller. So controller will depend upon business and logging service, and from main will run the effect. So first I will show the module button 1. I am creating a package object, and inside that I am just type aliasing the service. Let me import geo.everything. So what is logging and what is service, that we have to define. This is just a bundling step. Our module, we are giving a name like logging, and we are wrapping our service in a hash data type. We define a method. We will not focus on the application logic. We'll simply have some sprint line kind of stuff, but we'll focus mostly on how we compose different layers. So our log method is an effect. Task is nothing but geo, any throwable, and whatever the type. So we'll not return anything. It's a description which will return unit. So this is our service definition. Now we need to implement this service as a ZLayer. So conventionally, the name is given as live. We'll follow the same. As we saw earlier, we have various methods, right? So we will not use ZLayer.succeed, but let's say our logging service depends upon console and clock, which are provided by the Geo environment itself. So we'll create layer from services. Here we need to specify the types of the services. So we'll depend on console service and then clock service, and it will provide logging service. Since we are in scope, I am simply giving service. So that is the type. These two parameters will be available when this service is, this layer is created. So what we'll do, we'll create a new instance of service trait. This is simple geo code. Like we'll extract the current time from the clock service. then we don't care about the output. We'll simply log to console to give some timing information. And we yield unit. So this is our layer based on the service declaration. There is some boilerplate, but that is the recipe that is provided by Geo. So what else? We have the type alias, we have that interface, we have that implementation. Then we have to expose some method to the consumer of the service. So let's define that. We need to also provide the line that is provided, right? So this is interesting, like this is not a normal method. The consumer of this method needs to provide a logging layer because the logging service we are exposing is a ZLayer. So it's a geo effect which requires a logging layer. And this logging is not this straight, but this type, which is has logging the service wrapped in has. And since our effect is a task which can fail as a throwable, and it doesn't return anything, so that is the description of the layer which is exposed to the outside world. Did I miss anything? I think, yeah. So to run this log method, we need this effect logging, and way to access is like Geo provides one method access m. Underscore is the has type, then has as a get method, and get will get the service. So I get the method. So this is our capability exposed. Let me check what is the error. I missed the field. An object. Yeah. One more. So we have created a logging layer. To save some, now let's create a controller layer. To save some time, I have already created a business layer which will be similar. The controller layer I'll create as a module pattern 2, which will be less boilerplate and much similar to the object-oriented way. We created a trait controller. We define a method, say run app, give a name, which also doesn't return anything. We don't have to define type alias in this module pattern 2. This is service definition. Let's implement it. So here the recipe is like we create a case class controller live, that is a convention follow, and let's say it depends on business and logging. Makes sense. Somehow it's not able to find.
I think you have added case 2 times.
Sorry, instead of plus. Thanks. So let's say it depends upon business and logging. We implement the method. Result from business. Then we don't care output, just logging.log. Okay, we didn't define inside the logging. That's fine. Actually, we need the service. Sorry. And yield nothing. So we have this implementation, but it is not a ZLayer yet. So let's create a ZLayer as a companion object. This is very simple, like that's it. So this is much more cleaner than the module pattern 1. And only thing left is we need to provide a method to access from the outside. So also create a companion object for controller. Here we are not using type alias by wrapping inside hash, so that we will provide like explicitly. So our this method is a zero effect, which will require business with. Since I'm mixing module pattern 1 and 2, so logging is defined as module pattern 1, and we already have hash type defined. So we don't need to provide hash for logging, but for business, which is defined in a module pattern 2, same thing as we coded the controller layer. Here we don't need the hash type. So this is about the requirement, the R type. So this may fail with throwable and it returns nothing. Here we access the environment through access M. So this part is the hash, then we need to call get, then we can call the method in the service. But in module pattern 2, we already have another method like service with the type, then we directly get the service underscore dot run. Here we need to provide the job. Sorry, my mistake. This will be controller because whoever will call this run app from the controller need to provide a controller layer. Yeah. So I think we can, we have all the layers ready. Controller will use logging layer and business layer. And from main, we can simply invoke controller layer. So how do we run a Zio app? Runtime dot default dot unsafe run. Let's create a controller effect. Which will be nothing but this method. Controller dot run app. Say expand business. So can we run this effect? No, it doesn't compile because it needs a controller layer. Let's provide it a controller layer. We already defined a controller layer. If you observe, this is our, sorry, I forgot to name it. The layer is a controller layer. I can also define the type, ZLayer, which needs business with logging. Again, this is module pattern 1, so this is already type defined as a hash. This is the requirement input type of the Z layer. While creating the layer, we assume it doesn't fail and it provides a controller layer. So this is the definition of our controller layer. To run this effect, we need to provide it a controller layer. That layer. So let's provide it. Provide layer, but it still doesn't compile because if we observe, this controller layer has a dependency on business and logging. So unless we provide that, we cannot actually get a controller layer. So how we give business with logging? That is the horizontal composition. The business layer is defined inside business live dot layer plus logging. I need to specify the package name live. So this is module pattern 1, this is module pattern 2. So we have now combined layer, which is combination of service, business and business and logging. That is horizontal composition. But the controller layer needs this combined layer. So that is like vertical composition. We can give combine. That is the syntax for vertical composition. See, now it compiles. So we do horizontal composition, create a custom layer that we provide as a dependency to controller layer. So let's run it. Yeah, so this timestamp is got in the logging layer based on this console and clock. Then this message we pass to controller pass to business, and then it combined, and that is the output. That is the input, and that is the combined output. So we have coded a modular application which do fantastic things. And we have demonstrated horizontal composition and vertical composition. Yeah, I think we are on time. Let's have some questions, if any, or we can discuss anything else related to this topic.
That's really wonderful, Niloy. If there's anyone with a question, please ask.
Yes, I encourage everyone. If you do have any question, please ask Niloy. He's an expert person in all of those topics. Okay, so let's take this as no. No one has question right now.
Yeah. Yeah, no problem. I'm also, in fact, learning Zio. So I wanted to share whatever I learned till now. Anyway, you can reach me offline also. I'll try to answer if any question in the future.
All right, wonderful, Niloy, and thanks, Kuldeepak. This has been a good learning experience, I'm sure, for all of us, and we continue to learn, of course. And there's a next session which is going to start at 4:15. 5 minutes left. Take a breather, everyone, and let's make it
Yes,
a
Johnny.
fascinating learning day ahead today.
Yes, thanks everyone. Thanks Nula for this
Thank you,
wonderful
Tony.
session.
Thank you,
And
Kuldeepak. Thank you, everyone.
one more thing, if anyone is interested in learning Zio, so Noldas is on Udemy as well, and we have launched our first course on Zio as well. So meanwhile, if you do have any doubt and you are not means you are hesitating to ask now, so you can reach out to Niloy on GChat as well, and we will be good to answer you. Thanks everyone. Thanks to joining for this session. Have a nice day all.